The social aspect of doing science is really important. So I will include this later on. So I read these two papers. One of them is about electrospinning a polymer, another polymer, PVDF, and the other is about crystallizing PLA. I couldn't find a paper on electrospinning PLA because, well, it's not really something a lot of people do, but as a starting point, that paper about electrospinning PVDF may be a good introduction for me to understand how I may use the other solution, PLA, through this machine learning method. So we just want to see how values like the solution's concentration, electrospinning voltage, and tip to collector distance affect the nanofibers we get. So specifically, we look at the average diameter of beads, how big they are, or if there are nanofiber defects, like are there other shapes present? And there's also how different these beads could be from each other. Some of them are a little big, some of them are a little small. And then there's how much there are in a specific amount of space. So respectively, if you want to kind of have a shorthand for all of these terms, we're just going to use BMed, SDev, and BD from now on. So these two papers started by synthesizing their own stuff and using that data to come up with models based on machine learning algorithms. Bro, what the fuck does that mean? So for example, in the electrospinning paper, they made 126 plates of PVDF nanofibers, all with different values for the concentration, voltage, etc. These 126 plates are put under a microscope, and from the images of the samples, we can measure the diameter, the density, and all that crap, those BMed, SDev, and BD I told you about earlier. Okay, so now we have two sets of data, what we adjusted and what we observed. We want to optimize those things we observe. Okay, in some cases, we want 0 beads. We want none of those defects. And sometimes we want thinner nanofibers. The question is, what concentration voltage values do we need to get 0 beads, to get super thin fibers? By using the data we have, we can relate how these affect each other and use that as a guide to get whatever kind of fibers we want in the future. We have this web of data where we know this affects this or this affects this. But how much do they affect each other is what we have to know. So these relationships aren't simple. In some cases, we need to square the concentration value, while some factors have less weight. In other words, they don't really affect how the nanofibers come out. So exactly how do we determine those relationships? This is how those algorithms come in. An algorithm is just a set of orders that a computer follows to try to fit all the